Lesson 2.1 is on rational numbers. A rational number is any number that can be written as a ratio of two integers. Okay, our definition is right here. So these are some examples of rational numbers. 2 is a rational number because 2 means 2 divided by 1. Okay, we can put two integers, and one in the numerator and one in the denominator, and get an answer. So 2 is a rational number. -3 is also a rational number because if we put it over 1 and take -3 divided by 1, all right, we can get an answer. All right, so -3 is a rational number. -1/2 or even 1/2 could be a rational number. Okay, it's two numbers that are written as a ratio. A ratio looks like this. It can also mean that division line as 1/2. So I have two integers, one in the numerator, one in the denominator. 0.25 or 25/100. Okay, if I converted that to a fraction, I get 1/4. This fraction or ratio, all right, is written with two integers, 1 and 4. So it is a rational number. Now, the only thing that does not make something rational is if the denominator is 0. The denominator cannot be 0. We learned last chapter that you cannot divide by 0. Anything divided by 0 is undefined. So most things that you see are rational numbers, all right? The denominator cannot be 0 though. If I were to ask you to convert this fraction to a decimal, we are going to have to divide. You will put the numerator on the inside of our division and the denominator on the outside. Top number always goes on the inside. And then you have to ask yourself, how many times does 8 go into 3? Well, 8 goes into 3 0 times. It's too big. It does not fit into 3. We need to add our decimal and bring the decimal up and drop down a 0. Now ask ourselves, how many times does 8 go into 30? 8 goes into 30 3 times. 3 times 8 is 24. And we need to subtract, and we get 6. Add a 0. 8 goes into 60 7 times. 7 times 8 is 56. Subtract 60 and 56, we get 4. We need to drop down another 0, and 8 goes into 40 5 times. So our answer is 375 thousandths, or 0.375. Now, if I have a mixed number, all we are going to do is divide the fraction. Top number or numerator goes on the inside, denominator goes on the outside. 3 goes into 1, 0 times, it's too big, right? Add our decimal, bring it up, drop our 0 down. 3 goes into 10 3 times. 3 times 3 is 9. We see a pattern here. We have 10, we have 10. 3 goes into 10 3 times. 3 times 3 is 9. We're going to continue to get 3 every single time. So we can put a repeating sign above the 3. So it's everything. So 0.3 repeating, or 3/10 that is being repeated. All right, but we had a mixed number, so we cannot forget about this -2 instead of this 0. We took 1 and divided it by 3 to get 0.3. So I have now -2 point, because I have to continue to keep my -2, and then our decimal, this decimal is taking place of that fraction. If I ask you to convert a decimal to a fraction, we need to ask ourselves what place value this is in. One number to the right of the decimal is in the tenths place, so you put that number that you see in the decimal over 10, since it was in the tenths. If it was in the hundreds, you would put it over 100. If it was in the thousands, you'd put that number over 1,000. Here, 10 is part of my whole number, so I'm going to have that in my answer. Then I just need to focus on converting that decimal to a fraction. Well, how many numbers are after the decimal? 2, so that is in the hundredths. So I'm putting 25 over 100. And then when I reduce that, 25 over 100 reduces down to 1/4, so 10 and 1/4. The last two things I want to talk about are terminating decimals and repeating decimals. Terminating decimals end. Repeating decimals have a pattern that repeat. So I'll give you a couple examples of what a terminating decimal looks like. 3, it stops, right? 1 and 2/10 or 1.2, it stops. 375 thousandths or 0.375, it stops. Those are all terminating decimals, they end. Repeating decimals, it says the decimal that has a pattern that repeats. Okay, this is a repeating bar. It's saying that this 4 will continue to repeat on forever and ever. So 0.4 repeating is a repeating decimal. It may also give you these 3 dots, which indicate whatever pattern you have seen before those 3 dots repeats. So 0.3131, and those 3 dots are indicating that 31 is going to continue to be repeated. So 0.313131, so on and so forth. All right, homework is on page 48 and 49. We'll do 1 through 10, 19, 28 through 40 even, and 48 through 51.